so here we go. So let's get a little intro back into sequences and series, and let's figure out what all is what with that. Okay? Now, your textbook on page 794 has a wonderful explanation, refresher, if you will, of sequences and series. And it also, I believe the sequence one is on there too, but we'll get to that one in a minute. So, a sequence is a function whose domain is a set of consecutive integers. So the domain is the term number. Okay? So the domain here is our term number. So first term, second term, third term, etc. Okay? A sequence is a list of patterned numbers. Meaning there's some kind of pattern going on between them. It might be something like adding 4. It might be something like multiplying by -2. It might be something crazy as taking the square of a number and subtracting something else. You know, I mean, we can get funky with it. Okay? Right? But there's a pattern going on. Okay? The range then is just those terms. Okay? There are two different sequences. There's a finite sequence and an infinite sequence. A finite sequence has a specific amount of terms. It stops. Okay? In this one, there's 4 terms. That's it. Okay? If I added a term, then there'd be 5 terms, or so on and so forth. Okay? Finite stops. It's got a beginning, it's got an end, and there's a certain amount of terms in between. Okay? An infinite sequence, and you know that the sequence is infinite because of the ... that comes at the end, goes on forever. Okay? The pattern of the sequence is called the rule. Okay? So the rule is the pattern. The pattern is the rule. Okay? Again, all that information is on page 794 in the textbook that I gave you at the beginning of the year. Which, as long as we're speaking about the end game going on, you probably want to find your textbook at some point in time, because that's $50 that you don't want to waste. Okay? So, simple instructions say write the first 6 terms of the following sequences. So if I'm writing the first 6 terms of the sequences, I am going to take and I am going to put 1 in for n, because n is my variable in this particular sequence. So that's going to be 2 times 1 plus 5. 2 times 1 is 2, plus 5 is 7. Then I go on to the next term. The next term would be putting 2 into the equation. That gets me out 9. Next, put 3 in the equation. That's going to get me out 11. Next, put 4 in the equation. That's going to get me 13. Then 5. That's going to get me 15. Then 6. That's going to get me 17. Do I put 7 in? Why not? It's only asking for the first 6. Now, when I go to write that sequence, I write it separated by commas. So it's 7, comma 9, comma 11, comma 13, comma 15, comma 17. Okay? It is a list. Separated, each term separated by commas. Okay? That was an arithmetic list. If I do a functionized list, so then I would do f of 1. So that would be negative 3 to the 1 minus 1 power, which is going to be negative 3 to the 0 power, which is positive 1. Then I put in 2. Negative 3 to the 2 minus 1 power, so that's going to be negative 3. Then I put in 3. That's going to be positive 9, because my exponent is 2. Negative 3 squared is positive 9. Then I put in 4. That's going to give me negative 27, because it's negative 3 cubed. Negative 3 times negative 3 is positive 9 times negative 3 is negative 27. Then I put in 5. That's going to give me positive 81. Then I put in 6. And that's going to give me negative 243. And then I stop, because now I got my first 6 terms. So when I write this in sequence form. 1 comma, negative 3 comma, positive 9 comma, negative 27 comma, 81 comma, negative 243. Okay. What I would like you to do now is I would like you to find me the first 6 terms of those sequences. So, first term here is going to be negative 2 times 1, which is negative 2, plus 4 is going to be positive 2. Second term is going to be negative 2 times 2, which is negative 4 plus 4. That's going to be 0. Third term is going to be negative 2 times 3, which is negative 6, plus 4 is negative 2. Now, what do you notice about those numbers? Goes up by 2? Goes down by 2 every time. So we're subtracting 2 every time, right? So this next one should be negative 4, right? Okay. Negative 8 plus 4 is in fact negative 4. Next one should be negative 6. Negative 2 times 5 is negative 10, plus 4 is negative 6. And lastly, this last one should be negative 8. Oops, I'm getting ahead of myself here. That should be a 6 in there. Plus 4 gets me negative 8. So my sequence is 2, comma 0, comma -2, -4, -6, and -8. Okay. Okay. So if I put in my first, or put in 1 for n, that's going to be 1 over 1 plus 1. That's 1 over 2, right? Then I go to my next one. That's going to be 2 over 2 plus 1. That's going to be 2 over 3, right? What should the next one be? 3 over 4, right? And then 4 over 5, and so on. If you see the pattern, right, you don't need to do all that work. If you can do that pattern and recognize that pattern, you can say, well, this is 1/2, and then it's 2/3, and then it's 3/4, and then it's 4/5, and then it's 5/6, and then it's 6/7, because that gives me my first 6 terms.
Would you prefer that we write it out like that for the first couple? Because for me, I just wrote like A1 equals 2, A2 equals 0, or would you like us to write it all out?
That's up to you. Okay. Okay. Now, let's work backwards here for a moment. Okay. So if I'm working backwards for a moment, the first thing, or these directions, I should say, are pretty standard. Okay? So the first thing that it's asking is, it's asking you to describe a pattern. And that is going to be, you're going to use words to describe it. Then it's asking you to find the next term. The next term is going to be a number. And then lastly, it's asking you to write a rule for any term. And that's going to be an equation. Okay? So there's 3 parts to these directions. So first off, number 5. Describe the pattern in words. Okay? Well, I would say that the pattern here is that these are the negative cubes. One cubed is 1, then it's negated. 2 cubed is 8, then it's negated. Put it into my sequence. 3 cubed is 27, then it's negated. 4 cubed is 64, then it's negated. Okay? So my next term would then be 5 cubed, which is 125, and then negated. So my next term would be negative 125. Finding a rule for that, then, I would say that f of n here is equal to my term number cubed and then negated. Okay? What I'd like you to do is I'd like you to try number 6. Pattern in words. What do we got? But we're not adding 2 every time. Because then the third term would be 4.
Well, like,
So you're adding, right? Everybody agrees that we're adding. Consecutive even integers. Right? Because then you add 2, then you add 4, then you add 6, then you add 8, and so on and so forth, right? Okay, everybody agree with that? Okay. So what would the next term be then? 20. Okay. So, because the change is changing, first thing we should think of is a quadratic, right? Okay. A quadratic has a squared term in it. So if I'm going to have my f of n, I'm going to need an n squared in there, which is try. Okay. Now the downfall is this doesn't fit. My first term, 1 squared is 1, right? But I need it to be 0. So I'm going to have to subtract off something. What am I going to have to subtract off to get 0? 1 minus 2 is not 0. Now you can tell. 1? Okay. All right. So right now I'm at n squared minus 1. And that fits my first term, correct? That's just my first term. Now let's go to my second term. 2 squared is 4 minus 1 is 3. But I need it to be 2. N squared minus n. So let's change this 1 here to an n. Oops, that's not an n. Okay. Now it fits. Now let's go back and check it on the first one. 1 squared is 1, minus 1 is 0. Fits. Fits on the second one. 3 squared, minus 3. 6. Fits. 4 squared, minus 4. Fits. 5 squared, minus 5. Fits. Right? There's our rule. Okay? If it doesn't fit for a term that you know, that's not the rule. The rule has to fit every term that you know. Because then you can use it to find the terms that you don't know. Okay? Series now. Okay? A series is different than a sequence. A sequence is a list of all the numbers. A series is the sum of all terms. So a sequence we write with commas. A series we write with addition signs in between them. And then we actually do that math. We find what that sum is. Okay? Now, that brings into play something called summation notation or sigma notation. To refresh your memories with sigma notation, there is our sigma. Then we define some kind of variable. N, I, K, any letter there could be our variable. But that's the variable then that is going to be in our rule. And your rule is the expression Your rule is the expression that you get from the pattern. So like in this number 5, the rule would have been negative n cubed. The rule in number 6 would have been n squared minus n. Okay? You just take that and make it into an expression instead of an equation. Okay? Then you're going to have some starting value. That's going to be the first number that you plug into your rule to get your first term. Then you're going to go up by 1. Plug that number in. Find your next term, your second term. And up by 1, and so on and so forth, until you get all the way to your ending number. Okay? So you need those 3 parts in order to do sigma notation. Now, the actual wordage to go along with them, the index of summation here, that is your variable. The lower limit of summation, that is your start. The upper limit of summation is your end. Okay. So, let's do something here. Okay? Write the series using summation notation. So, the first thing we should do is we should find our pattern or our rule. Okay? Actually, let's go pattern here this way. Put it in the purple. What is the pattern of this sequence? Or of this series, excuse me. Plus 25, right? Okay. So what would my rule then be? What? If I went with a rule of n plus 25, that would give me 26 for my first term, 27 for my second term, 28 for my third term. So I don't like that one. What do we got? 25n. If I go with 25 times n, that tells me the first term is 25, the second term is 50, the third term is 75, the fourth term is 100. Does that fit? Okay, that one fits, so that's my rule. My starting value. I'm going to start at n equals 1, right? Right? Plug 1 into my rule, gets me out my first term. My ending value. Do I know how long I have to go until? I do? I don't know, right? I need my rule, 25n, to equal my last term, which is 250. So n here is 10. So to put that all into sigma notation, sigma is going to go from n equals 1 to n equals 10, and it's the rule that it's going to go by is 25n. Okay? In number 8, what's the rule? What's the rule? Yep. Okay. where did you start? Where did you end? It does say. Where? It ends at infinity because of the dot, dot, dot. So putting that one in sigma notation, n would equal 1, and it would go to infinity of my rule, n over n plus 1. What other stuff? This is everything else. Huh? Now, the last kind of problem is going to be where you actually have to find the sum of the series. So if you're going to actually have to find the sum of the series, what are you going to have to know? What? No? What? You got to know the parts of the series, which is the terms of the sequence, right? So you're going to start by putting in your first number, your starting number. You're going to put in 1 into your rule. So that's going to be 8 times 1, which is 8, right? Then you're going to go to 2. 8 times 2 is 16. Then you're going to go to 3. 8 times 3 is... Then you're going to go to 4. Which is 32. Then you're going to go to 5. Which is 40. Then you're going to go to 6. Why not? Because the n told me to stop at 5. So you're not going to go to 6. You're going to stop right there. Okay? Now, what are you going to do with 8, 16, 24, 32, and 40? You're going to add them all together. So 120 is your sum. You try number 10. So the trick on this one is you have to start with k equals 3. You plug 3 into your rule and you get out 8. So your first term is 8. Then you plug in 4, then you plug in 5, then you plug in 6, then you plug in 7, and that's when you stop. So you get all those, you get 8, 15, 24, 35, and 48. Add those all together and you get 130. Yes? Okay. Here is your homework. There isn't that much involved in it, so I think we can for sure have this one be due tomorrow. Okay. It's a couple of, write the first 6 terms. It's a couple of find the rule, describe the pattern, find the next term, write the rule. It's a couple of put it in sigma notation, and it's a couple of find the sum. Yeah. Much like what we did today.